topics. This morning we're going to take a quick look at an Audi A4 case study that's in for some repairs. The situation with the car is it's got some odd behaviour going on with interior electric stuff, so lights, wipers, indicators aren't functioning correctly, and the history of the car is it's been somewhere else. They've diagnosed a central convenience unit which lives under the passenger side on the floor. The convenience unit has been replaced, and unfortunately the symptom prevails. So it's booked in for us this morning to take a quick look, and what we're going to do is do this sort of process, evaluate what's wrong, take a look at the scan tool, pull some data together, see where we're going to test, if we need to get into the car, maybe take some measurements and see if we can work out what's going wrong. So I'm going to plug the scan tool in next, pull the data out, see what we've got, and yeah, let's take a look and see where it goes. So we plug the scan tool in, and we're using the CAN breakout box, which enables us basically to hook up to the vehicle's data link connector, and then we plugged our scan tool in the other side, and the scan tool we've connected up and done a quick test. And what we can see from the quick test are we've got 19 faults stored in this vehicle. So we've got faults here in the red, so we've got faults in the engine, we've got faults in the brake, 13 faults in the air conditioning, 4 faults on the dash panel insert. If we click through to the next page, we'll quit the quick test. So really, if we go to fault code report, let's take a look and see how those codes break down. What we're expecting to see then is the fault code listing clustered by control unit. So we've got immobilizer, engine electronics, and interestingly, the one fault we get to with engine electronics is data bus drive. So this is we think this is them meaning the powertrain data bus. Missing message from air conditioning control unit. So there's a comms error on the data bus, which sort of makes sense with some of the stuff we've got going on. As I scroll down through, steering angle sensor, voltage supply, I think that's because the guy had the battery disconnected because the wipers are going off continuously, sorry. Let's have a look. Air conditioning has got a rake of stuff in it. So we've got flaps. Okay, so they're local faults. They're not network faults because the flaps are connected to the unit. So they wouldn't be necessarily CAN faults, but we've got open circuit, short circuit to positive, so there could be some wiring fault going on there. Steering column electronic control unit, no communication, so the air conditioning unit can't talk to the steering column control module. That's really interesting because most of the symptoms we've got on the car, no flash, no indicators, and also no wipers, are essentially those are all originating from the steering column electronics control unit. Convenience central control unit, no communication. Let's have a look. Vehicle control 519, that's the unit. J519 is the main power control unit, so we get signals from the steering column into that unit, and then it essentially passes those messages on. So processes, the guy would turn his indicator left. The indicator left data signal would go down the data bus, it would connect to that power control unit 519, and that then would control the relay, which would bring the lights on. The same with the wipers and the same with the flash. So that sort of makes a bit of sense that we've got communication error and an issue. Let's have a look and see what else we've got going down. Group convenience system data bus, so convenience data bus in single wire operation. Okay, so again, that indicates we may have a wiring fault. CAN is great with 2 wires. Each of the messages on both of the wires are duplicated, so if we lose one channel or one line of the data bus, it will work in single wire mode. And single wire mode is set as a fault code. So again, we've got an indication that we may be looking for a wiring issue. Immobilizer control unit implausible signal. Okay, we'll bank that one, we won't get too excited. One other very interesting thing then here from the data, it didn't appear on our fault code list on the first page because it wasn't present. So electronic central electrics and also steering wheel electronics aren't communicating effectively with the scan tool, which again would say either you've got power or a ground to both those units, or the thing that links those units to my scan tool and to the diagnostic process is the network. Let's scroll down again and see what else we've got. Dash panel inserts got communications, no communications, vehicle electric, central steering column, climatronic control unit, group data bus and single wire mode. So the dash panel also gives us further indications that we're looking potentially for a wiring fault. Now, it could be a wiring fault, it could be one of the units on the data bus pulling that wiring down, it could be a chafe or a rub. So What we are getting from the scan tool at this stage is some indication that we've got a wiring fault and a communication issue. Let's scroll down. Steering column adjustment, navigation, interior monitoring, convenience system central module not present and or not communicating. Also, automatic vertical headlight aim control. It's got Xenon headlights on this car, so it has to have some level of control which is linked to the ride height legally, and that's not communicating either. And they're all sort of body chassis functions. I think probably the next step is we'll take a look at the online data system. We'll review what modules, in terms of the data that this is giving us, which of these modules that are affected on here, how are they hooked up together in the network, and we'll have an idea then of maybe making a test point and a connection. Scroll down. So voice control hasn't got, telematics hasn't got, parking aid hasn't got, telephone, ECU not present. Okay, that's enough for us to look at now. Let's go on and look at the data. Okay, so here we are to the test data, and we're going to take a look now at this Audi A4, try and get some diagrams up. Based on the data that we've got from the vehicle, we're going to take a shufty at 2003, it's a 2003 AWX engined 2-litre PD A4, so we want current flow diagrams. We're going to take a look at power, so we're going to go, based on the fault codes that we got, we're going to go power distribution, steering column control and or central convenience unit. We're looking for the data connection really between those things. So we're going to put power in our search engine. The search engine tries to do a predictive search, so as you type the numbers, as you type the letters in, it tries to categorize. So sometimes it's a bit funky with making sure it gets you what you want to get it, so we have to just check. So go to power and we search on then current flow diagrams, and we're using all data here, which is a direct replication of what we get with the Volkswagen system. So we're going to go for basic equipment, so we want to take a look at the stuff that's fitted to the car, and we're going to take a look and see what data comes up. So really we're looking for communication lines because of the codes that we've got, and let's see what we've got. So it's giving us main fuse, fuse boxes, relay locations and this type of thing, because we could have powers and grounds, of course, as an issue with the no communications. So we've got then earth points firstly, as we scroll down through more earth points, and then we start to get into some of the more interesting stuff. So we've got to the battery, main fuse, and then a splice with lots of power distribution. It's a Volkswagen diagram, so all of the component numbers are listed with a type that they are, and then there's a key over here showing us what that device is. So we're going to go down to, here we are, this looks interesting, J527. So J527 steering column electronics control unit, which is superb. This is what we're after. The symptom on the car, remember, is no lights, no wipers, no indicators, no flash. It seems to be the steering column control module is not working at all, and there are other issues. It looks like the alarm is setting off, the indicators come on randomly and just stay on. And yes, but our main function is lights, wipers, indicators. So steering column control unit over here has got obviously powers and grounds. We can see an arrow up here which says there's data further up the chain. So let's have a look. Okay, so we've got powers and grounds coming from this D, which is the ignition stroke starter switch. And then we're looking at A, B, C and D. They follow to the next page. So if we have a quick look there, that's A, B, C, D and E are all going into the steering column control. They're quite fine wires. The number on here indicates the dimension of the wire, and the letters underneath denote the colour, and then these are the terminals if we need to get to them. So let's have a quick look down and see where else we've got connected, because it could be the unit itself, but with several units offline, we would anticipate probably it's well, it could be power, ground or communication. Let's have a look. G85 steering angle sensor, E2 turn signal, E22 intermittent wipe switch. So all of our switches that aren't functioning are located on this diagram, which is great. We can see then, looks like the end of the control module there, and it's linking by these two wires by the look of it into two splices, and then these wires go to another unit, 509, onboard power supply. So steering column, which is where we're going to zone in, is connected to the onboard power supply. And actually what is very interesting, we can see the distributed function here. Connected to this unit on the previous page are my wiper stalk. These two wires, knowing a little bit about Volkswagen Audi, orange and brown, orange and green, of a very small dimension, 0.22, are very thin wires, and they look like they're CAN wires. It doesn't actually say it, bit of product knowledge there. So we'll have can high and can low body can going from steering column to the power supply, and the power supply then has got listed down here V12, rear window wiper motor V431, doesn't actually show us on there. V5 is another one, windscreen wiper motor. So we've got 431 and then V5 and V12. So there are the wiper motors. So we're in the right ballpark. So what I would suggest we do is we find out where this unit's connected, and we find out these wires, and we maybe get the scope out and have a quick look and see if we can look at some CAN signals. If we want to know where this unit is, because we're going to make a measurement here, we could do either here or here. This is going to involve stripping cowls. Let's see what's involved here. Onboard power supply unit. If we click the picture of the photograph, pardon me, itchy nose, the photograph should take us through to another link which should show us some idea of where the units are. Plan view of the car with all these little dots and dashes. So we're looking for onboard power supply. There we are, onboard power supply unit J519. If we click on the location, onboard power supply unit is located behind the driver's storage compartment. So behind a cover then, by the driver's knee. If we take the panel off, what we're looking for then is this control unit, and it's showing us there, number 1, the control unit lives there. So that's, we know where it is now. Let's have a look and see what the connectors are going to be like. The diagram, the wiring diagram, if we can find that page that we were on, will give us an indication of the type of connector that we're looking for. So we need to just scroll down, back through the wiring diagram to find those. We'll just scroll down through. That's the one. So we've got a 16-pin connector, T16A, on the steering column, and then we've got a T32B, T10. So T32 means there's 32 terminals in a connection, and there's a 23 and there's a 10 pin. So we're looking for the 32-pin connector, and we've got two. This might be difficult for you to see. 12 and 13, orange and green, orange and brown, are the communication lines between these units. So what I suggest is we get to the car, pull the covers off, get the oscilloscope out. I'll take a look around first, maybe get the scope out and have a look at measuring some signals. Okay, so we've got some covers off. I'm just going to lift the camera in here and see if we can see what's going on. Here we have the onboard power supply control unit as shown on the diagram. I've just taken this cover off, and what we can see here are wiring connector, and wiring connector. So there were 3 shown on the diagram, a 10 pin, I think this was a 23 pin, and then a 32 pin. So we've only got 3 connectors on there. So this little connector here up under looks like the one that we're after. This will be a push and pull. So if we push up and try and pull down at the same time, I might need to get a little screwdriver here to do this one. Bear with me with all the wiggles and the jiggles. So if I push that one in and pull it down at the same time, whilst I hold the camera, that would be a miracle. Oh. So I'm going to have to try and prop the camera here a sec. Try and get the light without losing the camera. Okay, much madness and mayhem. Okay. Camera's rested rather precariously. No, so 2 hands in here, pop it open, pop it down. Okay, make sure the ignition's off before we disconnect. Okay, she'll go to sleep pretty quick. Pop the connector off, and then we can pull her out. Okay, so there we can see our connector. What we know about this connector when we look at it, we have very smallly etched in there pin numbers, and that looks like 1 to 16 and then 17 to 32. So we've got 2 rows of pins on there. So we're looking at the diagram 12 and 13, which will be along this side somewhere. So what we need to do is just strip this connector out, pull this bracket off here, and then the interior of the connector will slide out, and then we'll dive in there with our scope and have a quick look and see if we can see what's going on. And we'll see you in a second. Okay, so we're back in here now. I've just taken the cover off, and so we're looking at the covers that way round. We're looking at 12 and 13, which are 2 pins in this side. So I've got the trusty Pico Scope, so I'm going to hook the ground up to the Pico. There. And what I'm going to do is pop the 2 channels in. So bear with me 1 second whilst we get the Pico Scope hooked up, and what we're looking for is, we'll try these disconnected first of all, 12 and 13. We'll just back probe those pins there. Orange, green, orange and brown. We'll try not to damage the pins is the trick here. We want to get them through so they're making a contact, but we don't want to either short them out, and we don't necessarily want to bend those pins. So let's just see what we can get there. They're connected. Okay, so now next job, let's whip back up to the scope and have a look and see, firstly with it disconnected, we'll pop the ignition back on, we'll get the network back up, and we'll just see, have we got data bus connection, what does the waveform look like, and do some basics just there. So bear with me a sec, ignition on and up to the scope. Okay, so we're going to fire the Pico Scope up now, so let's just have a quick look. Pico Scope Automotive. We're using the new 4-channel Pico here. Not that it makes an awful lot of difference. If you have a 2 or 4 channel, the old or the new, that should be able to cut the mustard here. We're back probing, so we're going to choose a 10 volt signal on both. We're not quite sure which way we've got connected up, and obviously it would be good if we had an issue with one of these or other, we could have a look. So we set a 10 volt DC signal, a 50 millisecond time basis, how it came on by default. We can zoom in there a bit and take a look, but what we know, without getting too excited, it looks like we've got a signal of plus or minus, so 0 to 4, 0 to 4, so body network, and the data messages at this level look to be okay. There's not short to positive, short to ground, and they look like they're sort of looking like each other. So let's have a quick look at the trigger. We'll set the trigger on to repeat trigger. And we'll set it onto channel A. We can go to a rising or a falling edge. We just have to make sure we get this in the zone. And what I mean by the zone is the trigger has to be somewhere within the amplitude of the signal. We've set a negative slope trigger. We set a rising edge trigger. We should set a negative, so a falling edge trigger. And then what we can do is adjust the time base and zoom in a little bit for a closer look. When we've zoomed in there, what we can see is our CAN network doing its thing. So one's at 5 volts being pulled down, the other's at 4 volts being pulled down. Let's have a quick look at how that looks. So let's get the cursors on here a minute, that will make it easier. So time-based cursors, there's my 0 volts, there's my amplitude there at this one, and the same with the red. I'm just going to use these two cursors, that's 0 and that's being pulled up to 4. So we can see the amplitude, so 4.9 volts on the blue, and we got 4 odd volts on the red. They're both starting off at around 0. I've got 11 millivolts on there. If I tweak this a little bit, it'll get to 0, and we can be somewhere near. So what we're looking at, there's a slight difference between the two signals, which is normal. Next question, I suppose, is which data bus are we in? There's a neat little trick you can do if we just pause that waveform. We think we're in a powertrain bus, we think we're in the convenience system, and one of the ways you can tell, if you've looked at lots of CAN signals, it's very easy. With this one, if you're not too sure and you're having a, it could be CAN, powertrain, it could be the body, it could be whatever it is. If you find the network message here, we've got one batch of data, and find the smallest bit, so the smallest either peak or dip, and you get your cursors out and you measure that, and you get an approximate measurement, and we've got here 10 microseconds. If I adjust that just so it hits the falling and the trailing edges, those two cursor marks will show me the delta. So the difference between the white one, start and finish, are these two values, and we've got 10 microseconds as a pulse width. We can do a rough CAN analysis here. We know that megabits per second is how we measure CAN. We have possibly 1 million bits per second is a megabit. Therefore, if one of these pulses lasted for 1 microsecond, we would have the capability of putting 1 million bits per second. If the pulse lasted for 2, we'd have 500,000 bits per second. If it lasted for 4, we'd have 250. If it lasted for 8, we'd have 125. And because we've got 10 here, that's we could get 100. So it's 100 megabits per second, this network. So it definitely is slower, 5 times slower than CAN. and the pulse width is showing me that definitely, yeah, that's a powertrain network. It's useful to do this test to know which network speed you're looking at, in case you sometimes have a short between your cans. When they when they go to a module, you're short, difficult to diagnose and very rare to happen, but you could have powertrain cans shorting out to the body can, and it'd be difficult to diagnose. This is one way to be sure the can that you're measuring. And obviously we're in a 100 megabit per second network there. If I play the scope up again, what we can see is there's not actually too much difference or difficulty in that signal. It looks good. The edges line up in terms of the leading edge and the trailing edge. In terms of the signal themselves, the edges are lining up, and the signals are reflecting one another. So you'd have to say at first glance that's not a major issue. So all I'm going to do now is go back to the car and do some wiggling, and I'm going to plug that connector in firstly and see with it plugged in, do we still have a good clear can signal? And then once we've plugged it in, we're going to see if the function on the car is okay, and if the function of the car is not okay, we'll do a little wiggle test while we're looking at the can and see if we can see what's going on. Okay, so we've been back to the car now, we've plugged the connector in, and what we can see between the difference between this high and this low now, we've still got the trigger set in, we're still zoomed in at 1 millisecond to watch the individual bit width, but what you'll notice is the top signal has now got some element of disruption on it. The bottom signal has become hairy, we can see these bits of interference, but the top signal is completely unrecognizable. What I'm going to do while the video is running is just dive back in under, disconnect the connection to make sure I haven't got a problem with my scope connection. I'm just going to pop the connector out of the control unit and see what happens to the waveform. If the waveform recovers, okay, so that we have then probably some idea of why we have a short circuit on that circuit. So I'm just going to try and get in there and plug that down. Okay, so this is it unplugged. So I'm going to pop that one out of the connector. Okay, so this is now out of the connector altogether, and we can see the can signal has recovered. I want to pop it back in the connector. Okay, and also what's happened there is I'm connecting that and disconnecting it. The wiper, you may have heard that in the background, is sort of half functioning. Let's put the indicator on. Okay, so now I've got an indicator, and I've got my indicators back. Let's plug that connector back in. And the indicators aren't functioning. So we can almost play a tune on this. With it disconnected, can signal's good. Let's put the wipers on because that's probably easier to hear or see. So it looks like then that unit could be shorting. There we go, we can hear the wipers running on the screen now. As I disconnect that and reconnect it, some of the functions are partly returning. Okay, very interesting. Now, let's have a think about why that could be. Okay, so I've got the wiring diagrams printed off from this car. We were looking at it on the screen, so I've done a screen print from all data, and I printed off the diagrams that we've got that concern our circuit, onboard power supply unit, and our steering column control unit, with the network wiring and the other things that connect to the output of that. We're interested in locally wipers in this case. On this one, we're showing the other connections here on my network, which are going to the central convenience unit, which looks after, remember, lights and locking. And then we're also taking a look at where else it goes, and it goes to the instrument cluster in, and it also comes out through the instrument cluster and goes to engine ECU. When we think about the fault that we've got two signals essentially on our network. We've got can high and can low, and can high is our signal that goes up, and can low is our signal that goes down. We've got an issue on our high, and our high is looking like it's very much disrupted. When we consider the way that the diagram's showing us the way it's connected, we've got several modules. We've got our onboard power control unit there. We've also then got our instrument panel. We've also got our steering column control unit, and we have finally, last but not least, our central convenience. When we look at our connections and the way the diagram's set up, what we're thinking is, essentially the way it looks if we draw the can in a slightly different colour, the onboard power supply unit is connected via two wires, which we'll call can high and can low, to my other units. So each one of them has got a connection, can high and can low, and we're taking the measurements with our scope that we've just seen at this point here, A, and at this point here, B, and we're getting our signal with it disconnected. We're getting a perfect signal, and we had to remember test it disconnected to be able to find the pins in the plug. We put it back together and plugged it in, and then we got our odd fault code. What we're trying to work out now is actually why the symptom is present with the waveform, and we're just taking a look at the layout of the circuit diagram to see if there's any way, or to try and work out what our conclusion could be about a diagnosis. The interesting fact is, if with this disconnected, so we have no connection near A and B, and we measure the waveforms across here, we get perfect can high and can low. Now, this is our first clue. If in our circuit somewhere we had a problem with resistance or a short in any one of these lines, we would expect these faults that were affecting this network to be present with it disconnected. The fact that that isn't present when we're disconnected, the waveform looks absolutely good when we've disconnected from the unit, leads us to consider two root causes. So root cause number one is we have a problem inside in the module. So when it's connected up to our onboard power supply unit, we are expecting some form of error, maybe resistance internally. When we connect it in, it's pulling that can high and making the waveform become disrupted. That's our first concern. That could be inside the module. If that's the case, we need a new module, and that onboard power supply control unit then will enable the network to start talking. But the second thing we have to consider is the way that the wiring loom is under the car. It's quite a tight connection, and so what we're thinking it could be is when we disconnect that plug and pull it down, the wiring loom is actually moving. So if we have a short somewhere in the wiring loom, the flex of us disconnecting and then reconnecting is making the wire loom go from a rest to a relaxed period position, is actually what's causing the difference between our good waveform and our bad waveform. So the next step now is to measure the can high and can low on the body control, to give the good test, a good sort of wiggle test on the wiring loom to see if we've got wiring issues that are causing this. And if the wiring loom checks out okay, then we can be pretty sure that we have an onboard power supply control unit fault. So, parts just arrived from the Volkswagen Audi parts supplier, so we've got a new onboard power supply control unit that's arrived today. And so what we're going to do now is fit this unit on. Looking at the unit itself, from the part number that we got yesterday, there is a supersession, so the suffix, the final part, the letter at the end of the part number is different. Obviously it's had some sort of revision. We've got a production date of 21st of 5th, 2014. It's made in Romania with the sort of genuine Volkswagen Audi logo on it. So what we're going to do now is fit this onto the car, and so we'll pull the camera around, show us fitting it in. We've still got the scope connected from yesterday, and we'll fit the unit on, we'll check the functionality of the car, and then we'll have a look at the waveform on the machine. So here we are underneath the car. I'm going to pop the camera there somewhere and see that we can have a good idea in terms of a shot that we've got. So hopefully you can see what I'm doing. So I've got the other unit unplugged from the test that we were doing yesterday. Still got the scope leads hooked up. So it's a case of ignition's off, system's asleep. We're going to line the connections up. So there's 3 connections we're going to make to connect this one back up to the car. The casing's made of plastic and there is no ground point, so it's having an external earth, so we don't actually need to fit it up to the car to get it to function. We can just rest it there. So we'll put the 3 connectors in. There, the 3 connectors are now in. We can see the old unit there stuck still in the car, so I'm going to pop the ignition on. and I'm going to grab the camera. So what we're looking for then, as I turn the indicators, oh there we go, indicator function left and right, and we can see then the screen is functioning as well. So it looks so far so good. So I'm back up to the screen now, and what we're going to do is take a quick look at some software that we've got running here. In terms of fault diagnosis, we've got the Diagnostic Assistant software here, which is really good. We've got network faults selected here, and in terms of background information, if you guys following this case study and want some extra info, if we select networking fault, we can see then the three items contained within the software, learn about the systems, carry out a test on the system, or see a comparison waveform on the system of networking. We can have a look at the CAN bus topic just very quickly, and this is just-in-time learning, so it will give you some idea of things that we need to know, and it gives us an idea of the CAN, LIN. If we scroll through the LIN, here's a bit about body control. Actually, this is very similar to the one we've got with body control, central convenience, the stalk in the instrument cluster, and the wipers. This one's slightly differently, that it's using LIN to drive the wipers, but the principal operation is very similar. And then we've got some network diagram and really of how the system works, how it's connected up, and some of the stuff we've been through. This is looking at continuity check. And we've got some comparative waveforms. So in terms of looking at waveforms that we were looking at earlier on, here we can see a known good CAN waveform. So that information's within the Diagnostic Assistant software. What I wanted to do now is just to hook up to Pico, so I'm going to fire the Pico Scope software back up, and as I look up Pico software and it starts to install, we saved the capture yesterday of the vehicle that we had with the faulty waveform. So if I select File and Open, we should be able to File, Open, Bad Body CAN, 1 millisecond time base. Just to give ourselves a quick refresher, this is what we had in terms of the waveform with the old module plugged in. We've just plugged the new module in. So here we've got a CAN, 5-volt CAN signal here, and the other one which is disrupted at the top. Now we plug the new network in. What we're looking for is we should get a good reflective signal. Hit the space bar. This is now live from the car, and we can see straight away the two waveforms that we've got. Good and bad CAN. We've got CAN going from 5 down to 1, and then we've got it going from the opposite way, from 0 up to 4. So, we could, if we were being absolutely technically perfect, we could put one above the other to take a look at the way that the network signals are going, but we're happy just to see that the signals are reflected, one to the other. So it looks like we could have a fix on this car. The CAN network signal's now cool. It looks like it should. The signal functions on the car wipers, lights are great. All that remains now, we'll plug into the scan tool, have a quick look for fault codes and data, basically clear that one up, and then we can count this as a fix. So there we have our fix. New body control module sorted our A4. We've been through a quick look around how to test the car. We used some data diagrams. We've used the scan tool to work out what's going wrong. We did some visual inspection, had a quick look, looked at the circuit diagrams to understand where we were. We made a scope measurement. We got a failed waveform. We changed the condition of the circuit to try and prove out was it the circuit or was it the control unit that was our first test point. We disconnected our faulty unit. The waveform came back square. We just made sure that we didn't have a wiring issue causing that fault, and it looked like we didn't. We committed to ordering a new unit. The new unit's 250 GB pounds plus taxes, and we plugged that unit on this morning. We verified the fix with the waveform. We verified the fix with the function of the car, and essentially we've sorted out this car, which previously has arrived here with another component fitted in a misdiagnosis situation. It's always difficult when you're doing these jobs to think about the way you would have carried out that repair. And sometimes when a job turns in with another part that's been fitted somewhere else that hasn't fixed it, it sort of makes my job a bit easier because we know really what it isn't. Having said that, I think you have to question sometimes the technician's ability to make a test and measurement on that car. Do they have a scope? Do they have a meter? Have they just got no cons with the scan tool and then gone for what's normally wrong with that particular car in the previous case? Or has it, like we've shown in this video, like I've shown, a bit of a logical process, some analysis, some thought, a couple of key tests, analyse that data, and then make your diagnosis is probably the way that I would suggest we go ahead with it. So thanks for watching, and we'll see you soon with another case study. Thanks. Bye.